Hello everyone, this is Sir Fredrick. So today we have interested topic radioactive decay and half-life. Now we are going to dwell much on graphs. So let me give you a quick background or information about this. Radioactive decay is the spontaneous disintegration of the unstable nucleus of an atom by emitting uh, actually the alpha, beta, and gamma radiation. Okay, so that's actually what it means, or what is radioactive decay is all about. So atoms, they tend to exist, them being unstable. So for them to gain the stability, they lose out, they emit certain particles such as gamma, beta, and alpha until they gain the stable nucleus. So as time goes on, they take time for them to decay. So for example, if we have maybe uranium, if we have uranium 256 as a mass number, as it goes, after some times, it decays by half of this original number. So after some times, that 256 as mass is going to decay by half. So after some times, we're gonna have 128 grams of mass of this one. So now, the time it has taken this uranium to decay by half of the original mass, which is what we are calling half-life. So in simple term, what is half-life? This is the time it takes for the unstable nucleus to decay by half of its original mass. That is what we call half-life. So half-life can be in minutes. It's a time. It can be in days. It can be in, actually, maybe let me put there, seconds. It can be in years, many years. All that is half-life. Remember, it's a time taken. So that's actually that that's what I can give you under this. That's the little information you can gain so that you do not get confused. All right, so let's then continue going, and let's have a question that we are going to tackle so as to understand these graphs of half-life. So we have a question. So the question is there. So the question is saying, after an accident at the nuclear power plant, a sample containing iodine 131 was found of the activity of 1,600 units or counts or liters. The activity of the sample was measured every 7 days, and the results are shown in the table. Okay, so these people, they were checking on this sample of iodine after 7 days, and this is what they found. So we have the table there tabulated for us. Okay, so how are we going to construct the graph? So the first question is saying, draw a graph of the activity against time. Okay, so what are we going to do? So let me try to put the use it as a graph. Okay, so if we look at the table given, you find out that we have how many variables. So we have 1, 2, 3. Okay, so we have 1, 2, 3, 4, 5, 6. So I'm going to find the boxes, 6 boxes, to accommodate this on the graph. So that's what you can do. So if you are using the standard graph, definitely it is 10 centimeter. Okay, so 1 centimeter represent maybe 1 unit. So you can use that, or 2 centimeter to represent 1 unit. So that graph has got a box. One box is 2 centimeter. So if you choose that 2 centimeter will be representing 1 unit, that's, you can go ahead with that, as long as you are going to find 6 boxes to accommodate this information. So let me take you back to the graph. So let's find 6 boxes and allocate them these. Okay, so I will let me try to put that. So my 0 will start from there. That's where I'm going to have my 0. Okay. 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 It can go like that. Okay. So in mathematics, this is actually y-axis. Then this side, horizontal, we are going to have x-axis. The vertical one is the y-axis, but this is physics. So in this horizontal line, we are going to put actually time. We're going to put time there. We're going to put time. So how much was time? Let me check from the question. So they were checking after 7 days. So my time should be indicated. So we are going to indicate here time in days. Don't forget to put that. The examiners would want to see what you are doing if you knew what you are doing. So that's time in days. So you indicate that, don't forget. Then what am I going to have here? I'm going to have counts. So counts. Okay. Counts. Definitely it will be in grams. If they have given you mass, use the mass that they have given you. Okay. So if this is my 0, so I'll put, so from the graph, the box that I was given, the table, I have these numbers as counts in liters. It was in liters, by the way. So 77, 140, 260, 270, 875, and 1600. So I'm going to start putting these units there. Okay, so I should have at least 6. So I will put 77 there. 77 on that. That box. So 77 to be there. Then the next number that followed was actually 140. So my 140 will be there. 140. Then the next one followed was 260. So my 260 will be there. Okay. Then the next one was 470. 470. 70. Okay. So my next one is 875. So 875 there. Then my last one, so I'll put it there, right there. So is 1,600 liters. So I'll correct my units there. They should be liters there. So it was in liters. Okay. So they said that every 7 days they were checking this one. So I'm going to put that time which I was given. Okay, so I'm going to put it. Let me hide a bit. So that's there. So I'll use 1, 2, 3. So here I'll put my 7 days there. So 1, 2, 3, 1, 2, 3. So I'll put 7 plus 7, that would be 14. Okay. Then that will be 21. That will be 28. Then that will be 28. So the next one ended on what? Ended on 38. 38. So I'll write like that. So now let us plot together. Okay. So at 0 we had I'll use a different color for the graph. So at 0 we had these. So 0, 1,600, it will be there. So I'll put the point right there. Then 7, 875. Okay, 875. So 7, I'll go up there until I find what? There. So it is somewhere there. Okay. From there, I'll go to 14,470. So 14,470 is there. Then the next one, 21,260 is there. Then 140, it's gonna be here. So 140 is right there. Right there. Then 38,77. So 38,77. So 77 is right there. Okay. So if we connect these points together, we are going to have something like that. Make sure you just use the free hand. Okay, you use your free hand to connect these points. Okay, there we are. So having done that, you've constructed your graph. Okay, so you've drawn your graph. So the next question is saying, from the graph, estimate the half-life of iodine. So that is question B. So I'll work on the same graph, question B. Okay. So they want us to estimate the half-life, because we are not given that this was the half-life, these guys, they were just checking on this iodine after 7 days. So let us try to find the half-life. Remember, for you to find the half-life, you need to get the original mass. So what was the original mass? So the original mass of iodine was actually 1,600. So what is the half of this? Definitely divide by 2. What are we going to have? We are going to have, you can compute that. We are going to have 800 mass as mass. So we have 800 liters. So where do we go now for us to find that? So this 800, you go and find it on the graph. Where are you going to use it? You go to the column where you put your masses, this your counts. So you go there, okay? You go there, check. So our masses in liters there on this line. So you go there and check. So we have 787 at this point. So definitely 800 should be between here, somewhere here. That's where we can estimate our 800 liters. So we'll start moving from there until we touch the graph. Okay, so we touch the graph there. Then you start coming down because you want to determine the half-life. You start coming down like that, the way I'm coming down right there. So I touch there. So if I have if my previous units is 7, so the 7 is between 7 and 14. So definitely here it could be 10. So the half-life could be 10 because it's an estimate. So it could be 10 days. So half-life can be 10 days. Okay. Others can put 9 days, 8 days. It's an estimation. So here I'm going to indicate half-life. So I've found what? Half-life there. So that's how you handle this type of question. So you estimated your half-life to be here. Okay. Now, having looked at that question, we had another question that was saying, what is the fraction left after 38 days? So how are we going to calculate the fraction? So C part C, I'll go to the graph again. So they told me that what is the half-life, what will be the fraction after 38 days. So remember, for us to find the half-life, this mass, which is 1,600, was decaying by half every time. So half of this is actually 800. That's what we found. So we'll say 1,600 give us, so on the first point it gave us 800. Okay, so here the fraction of 1/2, Again 800 on the second decay. So half of that it's gonna give us divided by 2, it's gonna give us 400. Again here we have the fraction. Okay, we get 400 on the third decay. So we have 400 divided by 2. We want to get the half of this. It's gonna give us 200. Give us 100. Again here we have another half, another equation, fraction, half. So 200 on the fourth, it's gonna give us 100. So 100, we have the fraction here. Okay. So as we are doing these points, this was decaying until it reaches 100. So the last one was 77. So we can no longer go any further because the last it was decay on 38 days. It was 77 there. So we can't go any further. We'll just determine the fraction from these 100 because the half of this one will give us lower than this and the days will increase here. So we'll get these fractions 1, 2, 3, 4. We are going to add these fractions. Then that's when we are going to find it. The fraction that was left at 38th day. So let me try to move this up. So we have how many fractions? We have 4 fractions. So okay, 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over 2. Okay. All right. If you want, you can add. You can divide this 77. This 100 into half, which will give you another fraction half for the accurately. But we're gonna end here. So 2 plus 2, that's 4 plus that one. So 2 plus that, 4, 4, 6, 8. So it is 1 over 8. That was the fraction. That was the fraction at 38 days. Okay, so that was the fraction left at 38 days. So you just add all the fractions, then you're gonna get the fraction remained. Okay, so this is how far we can look on the graph and solve this. So for more videos, feel free to follow me on Facebook. When you just enter Sir Fredrick, it will come. Definitely you can ask a question, you can hit my inbox or on the YouTube channel. You can also just search for Sir Fredrick, you find it rare. Thank you.